Forests, they keep our world healthy. We love them for their beauty and need them for their function. On its own, it can take centuries for a forest to get to the place where it is a light, dynamic haven. It must endure through extremes of weather, rebounding, changing, adapting to the extreme forces nature throws at it. A wood's existence is a never-ending flux of growth and destruction. In time, it may blossom into a rich old-growth stand, or it may get leveled again before it even has a chance. In nature, it takes time. More time than you or I will live. But with a little knowledge and a little planning, we can nudge her along, and it can happen in the relative blink of an eye. A forest is just another competitive system, and we can use our understanding of this system to move outcomes in different directions, accelerating the pace of change and restoring these dynamic ecosystems much faster and with greater success than if we simply left nature to its own devices. Look at this wood. Feels natural, right? Actually, it's a managed forest. All the spruce was removed in the 20s, and sometimes management can seem more natural than nature. In the early part of the century, massive clear cuts were done all over the Olympic Peninsula. Now about 40% of our national forests look like this. With intervention, we can watch this forest spring from dark to light within my school career. We can watch it grow from a dark cave that supports little more than a woodpecker or two to a cathedral of life, light, and diversity. It takes a long time for a stand to progress from dark stem exclusion to the diverse and dynamic ebb and flow of a mature forest. And I don't know about you, but I want to see our forests restored. I want to see them alive and light, and I want to see it happen now. I live in a part of the world where we can see the extremes. Old growth that hasn't seen trauma for hundreds of years alongside rich forests laid waste by volcano, flood, fire, and man. It would be great to see past harvested public forests return to a biologically complex form, to see foresters use science to accelerate the process. Here in the Olympic Peninsula of Washington is an expansive landscape where we have the opportunity to do just that. Welcome to our adaptive management area, part of a grand experiment using modern science and a testing ground for cutting-edge forestry practices, which marry sound environmental stewardship with timber production. The plan is to do a general thinning, keeping large patches wholly intact while introducing small gaps here and there, mimicking in sunny openings from natural disturbances. We selectively remove trees individually and in groups, eventuating in a canopy that reaches from the forest floor up to the treetops, providing a variety of microclimates that give habitat to a whole host of creatures. The application of harvesting practices are as complex as the resulting structurally dynamic forests. But best of all, what we can do in decades would take nature a century. So far, we're collecting baseline data on the pre-treatment area, on the forest structure, understory plant life, and soil biological diversity. Even though our study area is small, the research and policy questions this gives birth to are large. At the more basic end, we can look at the roles specific plants, bugs, and forest animals have in different treatments. This will be the first time anyone's tried to speed up stand development from an alder stand to a conifer by removing trees to release suppressed saplings, giving them a jump start in development. We'll also be able to see if removing nitrogen-fixing alder actually affects the amount of available nitrogen for the understory. For environmental analysis, we can follow what the timber products become and where they go, possibly charting the overall economic and environmental footprint. We can also analyze the cost and environmental benefit if energy-producing bioincinerator technology is ever implemented for use with the leftover wood products, a possible energy source that could sustain not only the harvesting, but perhaps even have enough energy to sell to the consumer market. We could also test the soil for the presence of methanotrophs, which are a soil bacteria that actually eat up methane. The tighter we lock up our forests, the more pressure is placed on developing nations to support the major economy's relentless consumerism habit. And what's left of the pristine rainforests in the Amazon, the awesome gorilla havens in India and Brazil, gone forever, harvested, then turned to farming. We need to set the example and lead the world in sustainable forestry. We need to show how with a little planning and thoughtful management, you can have it all. Beautiful forests with intact ecosystems, large trees that suck up carbon and help the environment, while still producing the products that our world has come to depend on.